Standard reduction potential. On this chart, there is certain feature. Based on the activity series, the top one, highly reactive. It goes down the trend to the least reactive. The tendency of oxidation, the strongly want to lose electron on the top. The weakly tend to lose electron, go down the trend. If you look onto the arrow of each, they are a double arrow. And there is a rule. Whichever go the reverse arrow, the reverse arrow means oxidation. If you go to the normal same arrow means reduction. Please remember, oxidation is a reverse arrow. Metal displacement. Metal displacement reaction. In this reaction, you put a zinc metal into a jar of copper iron solution. If you put a zinc metal into a jar of copper iron solution, you will find zinc slowly dissolving and copper iron deposit back into a solid. So you can see in these two metals, zinc is dissolving into the solution, copper from solution deposit into solid. So it is, you can say, zinc dissolve. What's mean by dissolve? Dissolve means you from solid become aqueous. From solid become aqueous. Copper deposit. What's mean by deposit? From aqueous solution become solid. From aqueous become solid. Student, you have to pay attention to the state change so that to guide you. Now we look on to zinc and copper. Zinc and copper, the reaction take place. If you put zinc and lead, reaction also take place. But if you put copper and zinc, no reaction. Student, you start to be a bit confusing. How come some reaction, some no reaction? When going to be reaction? Now is determined by the standard reduction potential table to determine. If you look onto the standard reduction potential table, let's highlight the metal solution on zinc and copper, zinc and lead, and copper and zinc. And now let's careful onto the state change. Zinc, the first one, zinc from solid become aqueous. So I put a reverse arrow. You from solid become an aqueous. Become. This arrow means you become an aqueous. So copper from aqueous become solid. Aqueous become solid. Look on to the next one. Zinc from solid become aqueous. Lead from aqueous become solid. Look on to the last one. Copper. Careful, this one. copper is from solid become aqueous. So this is a reverse arrow. So zinc from aqueous become solid. Now look at this trend. The top can react to the bottom. The arrow flowing from top to bottom, but not from bottom to top. So the last one have no reaction. It must flow from top to bottom, not from bottom to top. So the rule is the highly reactive metal solid can displace the less reactive metal aqueous. The highly reactive metal on top can displace the least reactive metal at the bottom aqueous, not the other way around. So the flow must be from top, arrow flow down the bottom. Repeat. From top flow down to the bottom, not from the bottom to the top. Not from the bottom to the top. Now we look on to the oxidation and reduction. Using the standard reduction potential table, look onto the zinc dissolved copper deposit. I highlight as before. Zinc from solid become aqueous. I choosing the reverse arrow. Copper from aqueous become solid. I use the same arrow. Remember, we learned oxidation. Reverse arrow in this table means oxidation. So you can put it onto the oxidation box. Zinc solid become aqueous and giving electron. Become aqueous with giving electron. Copper, same arrow. Aqueous become solid. Aqueous become solid. So this is the way to do the metal displacement determined by the oxidation reduction. And electron, you can see the trend. It flow from top to the bottom. Follow the red arrow. Electron flow from the top down to the bottom. Electron flow from the top down to the bottom. So if you look onto the oxidation point of view, oxidation, the atom give electron. Look on reduction point of view. Reduction gain electron. Now let's do more exercise. Sodium and iron. According to the flow. Oxidation, reduction. Sodium, reverse arrow. Iron, same arrow. Reverse arrow means oxidation. But one more step. Careful. 2 electron. This must be 2 electron. So these two must be the same. So what you're going to do? Put a 2. Now they balance. That's the way to do it. Do another example. Mg and Ni. Highlight. According to the flow, flow from top to bottom. Oxidation, reduction. Mg, oxidize. Reduction, Ni. Ag, Pb. Top flow to bottom. Wait, top flow to bottom. So, no reaction takes place because the Ag solid cannot become dissolved. Ag solid would not become dissolved. Pb will not become solid because this is from bottom flow to top, which does not happen. Student, I hope you can see the trend of top flow to bottom rule.